My name is Jason Farrington. I'm a math teacher in Gilbert, Arizona, and my favorite mega number is 18 quintillion, 446 quadrillion, 744 trillion, 73 billion, 709,551,615. I like this number because it's the answer to two legends in mathematical lore that demonstrate the power of exponential growth. The first legend says that when the inventor of chess presented his invention to the king, he asked in payment for a single grain of rice on the first square of the chessboard, 2 grains on the second, then 4, 8, 16, 32, 64, 128, and so on, continuing to double up to the 64th square. Now, you can see through this first row, it doesn't seem like much of a payment. But in order to continue to demonstrate the size of this request, we're going to need a bigger board. So now you can see we've got a much bigger chessboard, but we're still not able to get very far. We've got the same number of grains of rice on the first row up to 128. Then we've got 256, 512, 1024, 2048, 4096, 8192, 16,384, and 32,768. So that's how many grains of rice are on each square, but we want to know how many total grains of rice are on the chessboard. And you can see we start off at 1, then 2, then 4. That's 2 to the 0 power, 2 to the first, 2 to the second, 2 to the third. But if we add up all of the grains of rice up to that point, we've got 1, then 3, then 7, then 15. Now our pattern is 2 to the n minus 1. So 2 to the first minus 1 is 1. 2 to the second minus 1 is 3. So by the time we've filled up 16 squares of the chessboard, we've got 2 to the 16th power minus 1. That's 65,535 grains of rice just in the first 2 rows of our chessboard. Now that we know the pattern, we can figure out exactly how many grains of rice the inventor of chess in our legend was requesting from the king. We know that the formula was 2 to the nth power minus 1, where n is the number of squares that we've filled so far. So through our first 2 rows of the chessboard, we had 2 to the 16th minus 1, which is 65,535 grains of rice. But through the whole board, we'd have 2 to the 64th minus 1, which you may have guessed is 18 quintillion, 446 quadrillion, 744 trillion, 73 billion, 709,551,615. The second legend relates to this puzzle, which is known as the Tower of Hanoi. The goal of this puzzle is to move all of these discs over to one of these other 2 pegs. And there are 2 rules. One is that you can only move 1 disc at a time. And the second rule is that you can't put a larger disc on top of a smaller disc. So obviously, to move 1 disc only takes 1 move. To move the second disc takes an additional 2 moves for a total of 3 moves. To move the third disc takes an additional 1, 2, 3, 4 moves for a total of 7 moves. Now we've got these 7. To move the fourth disc, it's going to take an additional 1, 2, 3, 4, 5, 6, 7, 8 moves. So an additional 8 moves for a total of 15 moves. And then to move the fifth disc is going to take an additional 16 moves on top of the 15 moves that we've already done for a total of 31 moves. Now, the legend is that a similar setup to this was put in place inside the great temple at the beginning of the world. And the temple priests work night and day to move these discs over to another peg. The difference is that there's 64 discs in that great temple setup. And so the legend is that as soon as the priests finish their work, the tower will crumble and the world will end. So let's use the patterns that we found from this simple puzzle to determine how long it's going to take for the world to end. All right, so we said that to move one disk took us one move for a total of one move. Two disks took us two additional moves for a total of three moves. Three disks took us an additional four moves for a total of seven moves. Four disks took us an additional 8 moves for a total of 15 moves. And 5 disks would have taken us an additional 16 moves for a total of 31 moves. All right, so we can see here that we've got the same type of pattern happening that we saw in our grains of rice on our chessboard. So this is 1 is 2 to the 0. Let me do this in a different color. 1 is 2 to the 0. 2 is 2 to the 1. 2 squared, 2 cubed, 2 to the 4th, etc. And so in the total moves ends up being 2 to the 1 minus 1. That's the same as 2 to the 0. But now 3 is 2 squared minus 1. 2 squared is 4, minus 1 is 3. 2 cubed minus 1, 2 to the 4th minus 1, 2 to the 5th minus 1. So you can see that all we need to do is figure out how many disks we're using. That's going to be our n, and our formula is going to be, just as it was with the chessboard, 2 to the n minus 1 total moves for that many disks. So on the puzzle that I had, there are 9 disks. So that's going to be, that's going to take us 2 to the 9th minus 1 moves for a total of 511 moves just to solve that small puzzle that I had. Of course, for 64 moves, that's going to take us 2 to the 64th minus 1, which we know is 18 quintillion 446 quadrillion 744 trillion 73 billion 709,551,615 moves. So we've got a while. Even if the temple priests are moving those disks at a rate of 1 per second, that's still going to take them over 584 billion years.